Okay, I'm not there again today, and so I'm going to have to record this video from home and talk about using the combined gas law to solve some gas problems. So your objective for today is to follow along with your copy of the worksheet and for now just get some notes down. So to start out with, at the very top here, let's write down some information for ourselves. First off, that combined gas law. Again, as we found, the quotient of pressure to volume to the ratio of the amount of gas to the temperature is always going to equal a constant. So if we make any changes to one of those variables, then we should be able to calculate whatever variable it is that we're looking for. So we're going to be utilizing this equation to solve some problems. A few other things that we need to remember is that temp has to be in Kelvin. And to get the temperature in Kelvin, we take the temperature in Celsius and add 273 to it. Because only when we have the temperature in Kelvin do we have temperature 0 giving us pressure of 0. So we got to have that as well. Something else to remember is standard pressure. We talked about this a few days ago. Standard pressure being the pressure at sea level. And depending on the units, it could be 760 millimeters of mercury or 1.0 atm or 14.7 psi or 101.3 kilopascals. And then something else to talk about is standard temperature. Standard temperature is 0 degrees Celsius, which of course we don't want the temperature in Celsius, we want it in Kelvin. So 0 plus 273 means that standard temperature in Kelvin is 273 Kelvin. Okay, so we're going to need that information right there. All right, well, let's do the first question here. So the first question says, a sample of gas occupies 15.0 milliliters at 25 degrees Celsius. What is its volume when the temperature is increased to 60 degrees Celsius? And it says here that P is constant, so the pressure is constant, meaning that the pressure is not going to change. We're only looking at the effects of the temperature on the volume. And then you also notice in the title that it says that N is constant as well. So for all of these questions, the amount of gas is also a constant, which is why you won't see it here in our initial final effect table. When we solve gas pressure problems, we want to keep things organized and then also predict what the final answer should look like. And so that's why we have this effect line. So we're going to get into that right now. Okay. So a sample of gas occupies 15.0 milliliters. 15.0 milliliters is the initial volume. And so that is going to fall into the category of V1. So all of our number ones are in this initial line. And then next we have the temperature is 25 degrees Celsius. But again, we don't want Celsius, we want Kelvin. And so that's going to equal 298 Kelvin. And that's going to be my initial temperature. So we got that. And then what is the volume when the temperature is increased to 60 degrees Celsius? So we don't know what the final volume is. But we do want to know what it is when the temperature goes up to 60 Celsius. Which we add that to 273. And not even going to try. So 273 plus 60. That gives us 333 Kelvin. Okay. So that's all we got. Now, because pressure is constant here, I'm just going to put a little squiggly through it. And we are not going to worry about it. Now, before we get into the actual solving here, we wanted to fill in our effect line. Again, this is going to be our prediction for what the final answer should be looking like. So what do we know? we know that the temperature is increasing. Okay, temperature is increasing, so the question becomes, what is the volume going to do? Well, when we're looking at temperature's effect on volume, this is what we've been talking about for quite a while now. This falls under the category of expansion. When things get warmer, the particles move faster, they bump into each other more, they're going to spread out. And so we should end up with a volume that is larger than 15 milliliters. So it doesn't give us the exact answer, but we know if we solve the equation and we get a volume that's more than 15, we probably have done something right. Okay. So now we need our combined gas law. P1V1 and 1T1 equals P2V2 over N2T2. So again, all of my 1s is my initial line. All of my 2s fall under the final category. And so pressure is constant, so pressure is not going to have any effect on what's going on here. So we're just going to remove pressure from the equation. And N is constant for all of these problems for our first practice set. So we're going to cross that out. And really what we're left with is V1 over T1 equals V2 over T2. So now we're going to plug our numbers in. So V1, 15.0 over T1, which is 298. We're trying to figure out V2, and T2 is 333 Kelvin. So to get my final answer, I got to get V2 by itself, and how do we get a number out of the denominator? We're going to multiply both sides by 333. So we're going to have 333 times 15.0 over 298. That will give us V2. And so hopefully we get an answer that's more than 15. So 333 times 15.0 divided by 298. And we've got to 3 sig figs. These are all measurements, so we're going to need to pay attention to sig figs. 3 sig figs, 3 sig figs, 3 sig figs. Our answer should be in 3 sig figs. So 16.8 milliliters. There we go. Okay. So, there's our very first gas problem. We got to be able to read through the question and identify what is our initial pressure, temperature, volume, what is our final pressure, temperature, volume, what is the thing that we're looking for, and then make predictions about what it is going to do. Always, of course, remember as well that we got to get the temperatures in Kelvin. Okay, so that's always one of the first things that we should do. All right, so we did that question. That one had the pressure being constant. Let's do one where pressure, volume, and temperature are going to be changing. So we go down here to question number 4. What would be the new volume if 150 cubic centimeters of gas at 20 degrees Celsius and 710 millimeters mercury of pressure? So all of that is going to be my initial values. 150 cubic centimeters is volume. We've got gas at 20 Celsius. Of course, we don't want 20 Celsius. We want in Kelvin. So that's going to be 293 Kelvin. So 293 Kelvin. And the initial pressure is 710 millimeters of mercury. Question is asking what would be the new volume. So the volume is once again what we're solving for, so we'll put a little question mark there. If pressure were changed to standard conditions of temperature and pressure. So standard temperature and pressure. Okay, first off, standard temperature. Like we talked about up here. Sorry, my light's a little bright. The standard temperature is 273 Kelvin. So let's make sure that we've got 273 Kelvin in there. And then as far as the pressure, standard pressure is, again, if you look at the top in millimeters of mercury, it's 760 millimeters of mercury. So what do we see happening? We see the pressure increasing. If the pressure is increasing, then the volume should be going down because they were inverse of each other. So we'll put P right here in a little bracket, and we'll say that that is going to cause it to go down. And then we see the temperature The temperature is decreasing. And now we have the opposite of expansion. We're not expanding the gas anymore. We are watching it condense. So the temperature, since it's going down, should also cause the volume to decrease. So if we do everything correctly here, then our final answer should come out to be less than 150 cubic centimeters. All right, P1V1 N1T1 equals P2V2 N2T2. Again, N, we're not using it in any of these, so we'll just cross that out. But we do have things for everything else. So our initial pressure is 710. Our initial volume is 150. And that's over a temperature of 293. So pressure was 710, volume is 150, temperature is 293. Then on the other side, our new pressure, standard pressure, 760. We're going to be looking for the new volume, and then our new temperature is 273. That's going to go on the bottom here. And there we go. Okay. So then what are we going to do with that? Well, notice we got all of our numbers here. So we could solve this side. And then over here we got 760 divided by 273. We could solve that as well. So let's simplify. So 710 times 150 divided by 293. So that side to 2 sig figs is going to be 360. And it's 2 sig figs because the volume here was only 2 sig figs. And then 760 divided by 273. That's going to give us to, let's see here. Well, this side we got a bit of an issue because these are known values. They weren't measurements. So I think I'm going to keep 3 digits on this side. Not sig figs because they weren't measured. We just know what they are. So we get that times V2. Well, how are we going to get V2 on its own? We're going to divide both sides by 2.78. So that cancels out. 360 divided by 2.78. And so our final answer to 2 sig figs is 130 centimeters cubed is V2. There we go. Okay. So I wanted to go through a couple of examples of that. So hopefully you got those examples down. And for tomorrow, I want to see you work on the rest of this front page, so questions 2 and 3, and then everything on the second page as well. So I guess I should just say finish up the questions for the day. Yeah, that's it. We will take a look at it tomorrow. Again, just go ahead and do the best that you can. Okay, if you need to, go back and rewatch the video. And hopefully I return on, I guess it would be Thursday. So have a good day.